or shall I call you David for the matter?
Yeah, that's fine. You can call me David.
Thank you so much for the kind presentation. This was so interesting and very, very new for a lot of us here in Indonesia. And I also really, really appreciate that you mentioned earlier that actually concrete, even though it sounds like it's a material that has been used for many decades, actually it's always advancing, as the ACI motto says, and that we are actually still seeing new applications, new technology within concrete. And
very well, yep.
Yes, and another thing that I think we need to emphasize, as you said earlier, is that if our participants here are interested in joining the dual membership between Haki and ACI, they will get the access to the guidelines that can be used to design and all of the questions that will be answered here later on. And I will continue to remind you that this is one of the benefits of joining the dual membership. So without further ado, let's open the session of question and answer. Actually, there are so many questions. I'm a little bit shocked at how many questions there are. So let me combine them little by little, because
please do. I can't see that anything. So
yes,
I'll take your lead here to put it together.
Firstly, I think there is a question from Professor Professor Benjamin Lumantarna, and also by Pak William Suparjo. And the questions are a little bit similar. So you have already mentioned about the many benefits of SCC, self-consolidating concrete, but are there any downsides? And especially, I think they wanted to know more about the price comparison, like how much additional cost is SCC, let's say, compared to normal concrete. Actually, the question is specifically for the Indonesian setting, but I'm not so sure if you are familiar.
Specifically for what?
For Indonesian setting, so let's say SCC in Indonesia, but I'm not so sure whether you know. So maybe you can give us like an example comparison, or if you know if there are any regional differences in the SCC pricing. Thank you.
Okay.
That's the first.
Okay, let's talk about the disadvantage. Actually, it's a great question, and to have a talk like mine, it deserves to have some attention toward the limitations of SCC. The first that I would say is that your quality control issues with SCC are going to be more acute than with normal concrete. I have described to students that making SCC or working with it is like making concrete standing on the edge of a cliff. If you're on the cliff on the solid part, no problem. Everything's fine. You're stable. It works. But you're close to an edge. With SCC, if you just have, say, your stockpile of aggregate is a little wet, all of a sudden your behavior becomes unpredictably bad. And this happens in lots of different ways. So that's why I made the point about quality control is quite important. And I do think another disadvantage is I think the finishing is routinely not a very strong attribute, because what we do to make it a cohesive material that won't segregate are the same things that work to make it a sticky mix. So people trying to trowel a surface might have a harder time. I wouldn't do it. If I was doing anything with flat work, I would not do it. For one thing, SCC does cost more. That's maybe another limitation. SCC costs more. How much? Maybe not very much more, but somewhat more. When we did that project with the blast chamber, our concrete costs were probably only 10% more. It wasn't that much, because, in part, because of this. Our concrete supplier had made SCC before, had made quite a bit of it before. So they didn't think of it as unusual anymore. And so it was really just a little tweak to some of the raw material. And that's why they could do it, just a little more expensive, but not that much more expensive. I think what happens is that when you go to a concrete supplier for whom this will be their first experience, they might charge you a lot because they need to cover some risk. So it's not going to be easy to say. For me to comment on Indonesia, I need to come and visit Indonesia. So I'll come out there and learn more about Indonesia. But right now, I can't say very much about Indonesia. So, but that's my personal experience. I think that it doesn't have to be a lot more, but sometimes you may very well find it to be.
Okay, so this is very interesting. So as this is a very new technology, it's still dependent on the know-how of the industry, and it can really much differ whether you have experience in it or not. That I hear that's what you are saying.
That's exactly what I'm saying. You're doing well for me.
So maybe then later on we can go into the next question. So there are so many questions, especially because here there are people who are actually working in the field directly. So another question that is maybe related to the question before and your answer to that is that what kind provisions that should we pay more attention to when we work with SCC during the design and construction phase? I think you mentioned this earlier, but maybe you can emphasize again. And then the second question, it's still related, is that what work can go wrong during construction, and are there any recommended procedures for repairment in that regards?
Okay. Well, the first thing I would say about knowing about the different techniques for working with it, I would immediately fall back on the ACI recommendations. These are the questions that a committee comes up with. And what's nice about the ACI reports that are done is they're the consensus of 30, 40, 50, 60 experts working together. And so the language, how do you say this? How do you point out which point is more important than another? What are the words we're going to use? These are the consensus of a lot of people. And that's the beauty of relying on those ACI guides, is that they represent a lot of expertise. So with regard to, are there things that you need to pay more attention to? I'd first say I would go grab the document and read it for myself and see how it applies to my project. And maybe that would be what was the second part of that question?
What are the things that might go wrong during the construction work? And actually, maybe the more newer question is, what can we do to repair if there are any damages?
Okay. The things I know have gone wrong, in fact, I know there have been very severe conflicts and litigation, is related to segregation. I mentioned this idea that you're making concrete on the edge of a cliff. And if you are making concrete that might segregate, and you don't find out till near the end of the working day, this is bad news. It's all you may have trucks and trucks already into the job. So having your quality control on the job, working hard and keeping your company clear of those problems is so important with SCC, because the problems can come up fast and they can come up batch to batch. Having quality control on every truck, very important. We may not do that with normal concrete anymore. We sometimes get into a mode where we just run. But I would say with SCC, you need to have some kind of regular quality control checks. When you're pumping with SCC, there can be behaviors with pumping that kind of create segregation issues. You can create some kind of segregation. So doing trials, if I was going to go into a big project with SCC, I would definitely do mock-ups of the walls and of the forms and of the pumping system before I even do the real project, to make sure my team and my mixture is the right kind of mixture to serve the job. Don't go out to the project on the first morning and expect perfection. You need to work it through. So there's a couple ideas.
Okay, so really quality control is key here for doing SCC, yeah?
Yeah, I think so.
So another question, and this has many actually have the same question, is about the concrete strength, like the full concrete strength, because what is actually the maximum strength that the concrete will be able to reach? Is it lower, for instance, than normal concrete, or does it reach like a higher level later on?
No, I think it's safe to say that the majority of SCC being placed is a modestly higher strength. Remember, the main thing that we're doing to get that workability is we're shifting our paste content to be higher. So we have generally more cement water. The paste content is a little higher, but it also means that you have an opportunity to control the water cement ratio. You can make SCC with a relatively low water cement ratio and get high strengths. They do. I mean, we've seen it done. This SCC has been used on the Trump Tower in Chicago, one of the tallest buildings in Chicago. It's been used on big projects like Burj Khalifa. It's not uncommon. And where we need high strength concrete, it has been used successfully.
Are there any differences in the curing methods for SCC? That's also another question.
No, so I would say that
28th day, everything.
I think in many regards it's similar in that. I would say, however, you might see some. This would be another limitation issues. Remember, we're kind of concerned about the workability window. So controlling that is kind of important, and it could be that you're going to use retarding admixtures to keep that open long enough to have the right kind of behavior. On the other hand, you might even find projects where you use accelerators so you get a higher stiffening rate. I've actually heard both of these things being done. So there's some kind of cases where you want it to be relaxed and slow, and other cases where you need it to be a more rapidly setting up and stabilizing material. So let's just group this to make this a collective remark. The control of admixtures and the control of set affecting admixtures gets to be a kind of an important part of SCC technology. When you're designing the mix for your project, you're undoubtedly going to have some constraints from the project on these issues. How fast does it need to do? How many days do we have to do this? Do we have for the project? All these things are coming together. And the advice that you get about how you control and tweak your admixtures is going to be part of that discussion. But this is actually part where I think this is such an important part of concrete technology. Set control, fluid workability control. This is the future. The most sophisticated materials we're doing now have set control and workability control. It's fascinating what concrete can do for projects that are real demanding.
Thank you, Professor. I can hear your passion in your answers. You're so excited and pushing concrete as the future material.
I'm pushing education too.
I can hear it. So basically, actually, you already touched our next question. So, but perhaps you can elaborate more. The question is there any more explanation about special admixtures or different, like that can be used inside SCC that is different with normal concrete, or what are the kind of admixtures commonly used for SCC to get optimum performance, and of course how this will affect the strength and behavior that happens to that concrete?
Well, the admixture story has been amazing over 30, 40 years. We started in the 1980s with water reducers, we call them. And then they were high range water reducers. And then they were super plasticizers. And now they're the super plasticizers with viscosity modifying ability. And so the admixture companies keep upping their game and creating better and better benefits and control for concrete. And that gives us simultaneous control over water cement ratio, which then dictates the strength, as well as the workability and the time window for workability. So all these things, the partnership that you have with your admixture supplier is just very key. all the major companies have good modern admixtures for SCC. They want to be in the game. This is where their industry is heading. So they have good advice for you. And but the trick is to know which company you're working with, and maybe locally which team of experts is most responsive to your company and so forth. Those are more individual characteristics. But I've worked with people from all the main admixture companies, and I can guarantee that they have experts that know this stuff well. This is not easy material. They have good laboratories. They know what their admixtures can do.
Thank you very much, Professor. We still have more questions coming up. So other questions is actually now related to initial setting time. So is there any correlation between SCC initial setting time with the pressure? And then what is the initial setting time for SCC?
There's no single answer to that. Because this is the part of the game where we can design a concrete to do what we need it to do. I would say that the open time for working with SCC starts by being reasonably similar to regular concrete. It doesn't have to be that different than regular concrete, but if you have in your company experience with pumping regular concrete, you're part of the way toward understanding what you need in SCC. There's, I guess, in answer to that general question about are there standard setting times or stiffening times, there is not. And that's why you want to do the testing so you understand what your material should do. Let me tell you, you know what? There's a subject that I have not given much emphasis to. Let me bring it up at least right now. I said that SCC differs from normal concrete in part because it has a higher paste content, right? Now, somebody out there who's really a smart concrete materials person would say, higher paste content? Huh. That should say that SCC might have higher shrinkage. Drying shrinkage.
There's a question on shrinkage here.
You're right.
We have a lot of smart people.
You're right. And that means that you better test for that. And furthermore, I'm astounded by how this material, you don't see shrinkage in specs very often. It should be there. You might want to put it in your project specs, because if your architects want a crack-free material, crack-free walls and so forth, you might want to think about the shrinkage issue and impose on the concrete supplier a maximum shrinkage. I would, if I was doing that. So anyway, I should have mentioned that as a limitation, that when you modify, move away from normal concrete one way. Actually, good concrete today, as just a general thing, we should have it with as little paste as possible. It's more sustainable, lower CO2 footprint. The green issues. You have better volume stability. There's a lot of reason to try to get rid of the cement.
Yeah.
To reduce the cement, minimize the cement.
Yes.
And SCC doesn't always help us get there. So
I love that the more questions come in, the more information we get, and the more we can see the benefits and the limitations of SCC. This will bring the conversation forward. We still have many questions. I think we still have time, so I think I will continue.
Well, you judge that. I'm happy to be here as long as you need.
Okay, so another question. So there are questions about creep. What is the creep on SCC? You mentioned shrinkage compared to that on conventional concrete. Can it be estimated using ACI creep prediction formula, or are there any limitations of using SCC on structures?
Okay, the creep issue, it really goes together. Our group has done a lot of work on shrinkage and creep over the years. Especially on early age. This would be within the first 7 days. And we've even, I don't know, but probably, I don't know how much of my papers have been on that, but probably that's one of my favorite topics. But the point you're making is right, that if we expect more creep, we have more shrinkage, we have reason to suspect there's more creep involved in it too. After all, the part of concrete that undergoes creep mechanisms is not the solid rock, it's the paste. So if we have more paste, we have higher creep potential. Now, I have to say that most time people don't worry a lot about creep, but if you're working on a big project, a high rise, a big, these kind of projects, it may very well pay for you to ask questions and do testing and have your materials experts think about the effect of shrinkage and creep on longer term cracking issues and so on. Definitely, it's an issue. It's part of the basic mix design that we're moving toward a material with higher paste content.
Thank you. Thank you for the answer. I hope that this answers the question. We still have more coming up. So another question is about the compression behavior of hardened SCC. Is it the same as the compression of hardened normal concrete? The ratio of FA to CA aggregate in SCC is higher than that in normal concrete. It is known that compression behavior of concrete is affected by coarse aggregate. So that's the reason why the question was asked.
Yeah, my first answer would be they're basically the same, but the person asking that question knows some details because he's talking about the fine aggregate to coarse aggregate ratio. And if you go back to some of the concrete textbooks, there will be some information about how creep and shrinkage and volume stability and compression behavior and even fracture is affected by aggregate gradation. So I'm going to say as a basic answer that it's not going to be significantly different. Your compression behavior will be basically the same. Your elastic properties are going to be basically follow some of the same relationships we have in the textbooks, with the caveat that there's always a little change because of these issues we're talking about with the paste content. But you should be able to calculate that. If you go back to the basic, my favorite concrete textbook is Mindus and Young. The name is concrete. There are relationships that deal with the aggregate gradation and so forth. And these are basically rule of mixture kind of relationships. But they're handy to give you an idea about how much certain mechanical properties might change.
Thank you for the question. Next up, we have more practical application questions. So there are questions about application of SCC in large projects. So is SCC good for concreting large area when we want to concrete at the same time, like concreting for rough foundation? And also, let's say for an application in board pile foundation with dense reinforcements arrangement located in shallow, fresh or salt water. For example, in bridge pile construction, is SCC also recommended?
Yes. The answer is yes. That's one of the popular ways that SCC is used. I know that SCC has been used on some of the tall buildings in San Francisco, for example. Anywhere where you have these deep piles, your ability to vibrate is very limited. Your ability to observe directly is very limited. You need the self-consolidating character of these materials. And SCC has sort of become almost in the family of grouts that we're using for space filling in geotechnical / structural applications, foundations of tall buildings. And I would bet in Jakarta, this is actually a pretty common issue because your city is going vertical real fast.
Yes, very fast.
Yeah,
yes.
Yeah. And so the SCC technology represents some great advantages, and I would guess that's where you're using that. And you know what's also nice about those tall building projects? They've got enough budget to handle it. The materials budget isn't the limiting factor. In fact, time can be the limiting factor.
Very true.
And SCC is an answer for that. SCC can open up the door to some very rapid construction schedules. So.
Okay, so we hear a lot of benefits of SCC. I hope everyone's listening. So maybe next time for their big projects, they will think about SCC, and maybe we can have Professor Lange coming directly to Indonesia to explain us more about SCC. But we still have more questions. It's amazing. The questions keep on coming in, and because this is such a new topic,
but you have a schedule to keep. Don't let me ruin your schedule for the day.
No, I was actually, of course we have a schedule, but because this was such an interesting presentation, during your presentation, I was already told that it's okay, Asi, just let the questions come in so that everybody can get as much information as possible. So we are extending the question and answer session.
Well, good. I'm glad you're enjoying it.
I hope you're fine, because I know it's like 10 p.m. Like,
I love to do this. I love talking. You know what I hope is the real message of all this? If you're getting excited about this kind of talk, you should get excited about the ACI partnership.
Exactly.
Yeah.
This is where we're going with this. So, okay, we have more question. Wait, I will go to the questions about the guideline later on. So another question is that how durable is SCC concrete compared?
Hold it. There's one thing that just came through. Before you go on to the next one, somebody's chatting here. In Indonesia, 1 cubic meter normal concrete has a certain price, but SCC has a 4 times higher price. Is that real?
Correct. That's not correct. I've been using SCC in my project. That's not correct.
Okay.
Okay.
But maybe what it does, okay, let's give some benefit of the doubt here. You know what can happen is that there can be projects that are affected by other parts of the story. This is not just a materials cost. This is also like mobilizing trucks and mobilizing equipment and mobilizing the pumps and so forth. So it might be a complicated answer about what the real cost is. Okay. Go back to the question.
Actually, this was like, I think this was part of your answer in the very beginning. So SCC is a relatively new technology, as you mentioned. So it really depends on who we are working with, and like the expertise, the experience will always affect the pricing. So perhaps by having more projects with FCC in the future, it will definitely reduce the cost as the experiences.
No question.
Of everybody.
Like any of these technologies, the more we use it, the price goes down.
Yeah, so perhaps this is our work together if this is something interesting for us to apply in the future. So other questions. So where was I now? Okay, how durable is SCC concrete compared to other high strength concrete such as ECC?
Yeah, it's very durable material. I would say one thing we've talked about already that would be something to keep your eye on is shrinkage cracking. When we talk about durability of concrete is a very durable material, and any modestly high strength concrete is a very durable material. We don't have to worry too much about that. But when we start having cracking, that opens pathways toward, the seawater, and we get an intrusion of salty water into that starts corroding rebar or such things like that. That's a different kind of workmanship issue, and it's a failure. It's a failure not to think about all parts of our project, that we allow our mind to be set just on strength, for example. But this was it was a high strength concrete. Yeah, high strength concrete with cracks in it. So you've got to be realistic about the full picture of the performance to claim that it's going to be durable. But otherwise, I don't have any hesitation to say that SCC is going to be a very durable material. Normally it's a relatively low water cement ratio, tight, high strength material. Good stuff.
Okay, so the next question is a lot about design again. So how do we calculate the mixed design for the material for SCC? And let me see if we can combine it with another question. Maybe you can answer that first, and then I will go to the next.
Okay, mixed design. That is getting to be a complicated answer. In the previous years, you could say, "Oh, gee, just go to ACI 211. They have a mixed design method. You do this thing, and you take the slump you intend to have, and so forth." The mixtures today are more complicated, and I think it certainly is good to pay attention to the basics, old-fashioned technology, to get the right proportions and to honor what we've learned from the proportion of aggregate, the trying to reduce paste content and things like that. But when it comes to putting it together and getting the real mixed design, you're going to have to pay a lot of attention to your admixtures and the behavior of those things working together. So I think a lot of the mixtures being designed today are again coming out of your experts who work with the admixture companies. They can help you with mixed design. I'm not sure quite how every company might be designed today. If they have, I mean, the ready mix suppliers I know, they're so old, they're so traditional that they have mix A, B, C, D, E, and they just pull one off the shelf, and that's what is going to be delivered. They don't even redesign it. They're not really redesigning new mixtures very often. So I don't think I have a great answer. There's probably somebody who can answer this better than I can, who's in the audience here. But I would say you want to do it hand in hand with your admixture experts.
Yeah, so
where's another question? Yeah.
Well, actually, the other questions is a lot related to the Indonesian standard, and we have here a lot of the experts in concrete in Indonesia as well. So maybe maybe Bu Yani can also help answer this. So right now,
let me say one more thing about experts. Yes. While we're on this thing. You notice how as time is going on, our need to have really deep expertise and really educated people working here, it's getting more and more. In the old days, ready-mix concrete producers, suppliers, they didn't employ engineers. They were traditional operations. They were field workers who put this together and followed some standard practices. But this is changing really fast. And what this is a challenge to our university system, and it's a part of how we might want to communicate with the students coming out of the university, how construction has a huge need for your expertise for this new knowledge. You're not just going to go work in research. We need you on site. We need these students who have gone through these projects and know how to deal with complex behavior. We need them on site. So anyway, it's just a testimony to how construction today is serious business, and the money flowing into this and the affordability of really getting our best students to be on site and being part of the project. This is all happening.
Yeah, it's an exciting time. It's an exciting time where engineers will get more and more jobs. Yeah. That's what I'm hearing. So actually, a lot of the questions is about how we can design SCC in Indonesia. Like right now, we don't have guidelines, for instance, here in Indonesia. But here, I might also add, this is one of the reasons why we are having this event today, because we are going to start a dual membership between ACI and Haki, which means that if you become part in this dual membership, you will get the chance to actually have access to all of the guidelines that ACI already has that we don't have yet in Indonesia. So this is one of the benefits. Please keep that in mind. And now, before this is actually, I think we are almost out of time, but because there are so many questions about design, I would like to address the question as you have already suggested to one of our members here, another panelist, Pak Davi Sukamta, who had already, as he mentioned, designed by using SCC, and maybe he can explain to us his view or his experience in using SCC in Indonesia. Silakan Pak Davi.
Okay, thank you. Good morning, everybody, and good evening to David.
Hi.
I've been using SCC for some of my projects, and the main difference in Indonesian practice to those in US is, I would say, in the work culture. So ready-mix suppliers in Indonesia, normally they don't do strict quality control. For example, for the aggregate, the stockyard, they do not cover that with roof. So when we start the project, we must have an adequate time to talk to the ready-mix supplier, making trials, do real delivery to the site, collecting the information, do statistical analysis, and then we are confident that the strengths, the characteristic can be achieved. We also force them to build a roof cover on top of the aggregate. And if there's a change in season in Indonesia, we only have 2 seasons, dry and wet seasons. There will be a change in the moisture content and the lump in the materials in the aggregate as well. So we have to test that as well. So it's more on the work culture and on the discipline of the people itself. But myself and my company is also pushing to that direction. We have used currently 70 MPa concrete with SCC for vertical components of a 63-story buildings. That's my experience.
Thank you so much.
Let me just respond to that, because what you're saying there is absolutely true, and I completely agree. We're on the same page on that. And I would say further that when you have this kind of a gap of performance in the commercial marketplace, I personally would say that's opportunity. That's opportunity where the smart company, I make money, baby, because I know how these things work. And if they want to come to a company that knows how it works and delivers quality, you come to me, because there is this traditional problem that you're talking about. So I think that, but we need to elevate the whole industry too. I don't want to just say we leave everyone one below, but it is opportunity for people that know how to solve the problems to do better and then gain reward for doing better.
Thank you so much.
One more thing.
Okay.
On the making the samples and testing the cylinders, the standard is not that high. If I use high strength concrete, for example, with SCC, we may have low results. It's not because of the material, but because of the testing procedures. From taking samples, curing, capping, doing the test, with a rate of loading which does not follow the ASTM standards, and the capping of the cylinder is also not properly conducted. So the whole steps from mix design, placing, taking samples, testing and evaluation has to be redefined in Indonesia.
I don't have anything to add to that. I mean, you're giving a good example. Yeah, that's a good example.
Okay, thank you so much for Pak Davi and also Professor David. So basically, we hear already so many benefits, and you heard David say before that actually, if you are now deciding to join part of the dual membership between ACI and Haki, then you will be at the forefront of this discussion, and you will learn to have all of these expertise before everybody else has it. And of course, there are so many benefits to that. And this is one of the things that we want to say today in this event. And I already hear so many curiosity on how you can actually be part of this dual membership and theme today. So after this, I will give back the floor to, I think, Mbak Dila here to tell us more, Mbak Dila and Bu Yani, to tell us more about how you can actually be part of this dual membership, and you can get all of the benefits of being at the forefront of the discussion in SCC and apply it to your projects. Thank you very much for listening to us today.
Excuse me.
Also, Professor, we will have Prof. Iswandi, our head of Haki, speak later on. If you are willing to join us, you are welcome to do so. Maybe I don't know how many more minutes, but
okay.
if you're too tired, I understand it's like 10 p.m. there. It's also okay if you need to leave. It's fine. But anyway, thank you so much.
I just want to make sure. I'm not sure that Professor Iswandi's speech will be in English. I think it's in Indonesian. So then,
okay.
So then for David, that would be.
May I add a little? Excuse me. My name is Rajat. May I ask a little?
Silakan, Pak.
Hi, David. I'm class 83. So it's nice to meet you. I just want to add something there from Pak Davi comment. That the basic problem we have in Indonesia is because of the consultant of management construction is not doing their job properly. That's the problem. They are just doing as if they are delivering a letter or comment from one hand to another, but do not properly assign qualified engineers to control the works in the field. That's it about it. Basically, that is the main problem, I think. Thank you.
Thank you so much, Pak Derajat, for the kind additional insight into the situation in Indonesia right now. I think we need so much expertise, more information later on from people like Professor David to explain and to maybe tell us more about SCC. And this is just the very beginning of our long collaboration, hopefully, between ACI and Haki. So expect more of this type of event coming on, and then we can hopefully get more technology transfer. So because of the limited time, I will immediately give back this floor to Bu Yani to explain us more about the dual membership. So Professor David Lunch, thank you so much for your time. I know it's so late, and see you in another time. Thank you.